4-2, graphing linear equations. Two important things to know before we start graphing. This is an equation written in standard form. It's got some number and an x plus some number and a y equals some number. That's called standard form. Slope-intercept form has the y value equals a number times x plus a number. So two different forms. You have to be able to change back and forth from one form to the other, and it's fairly simple, and most of us have already learned that in the previous lesson. Here's some examples of standard form and slope-intercept form. Which is which? Well, the first one is standard form. The second one is y-intercept form. And not y-intercept form, slope-intercept form. Slope-intercept form. The third one is standard form. Okay. Here we have standard form. This is the standard form of a linear equation. And here are two ordered pairs. One of them is a solution to this problem. One of them is not. The directions with this usually say something similar to this. Tell whether the ordered pair is a solution. So we're checking the solution. It's sort of like the checking part of a solve and check problem, only now we have two variables, x and y. So to find out if it's a solution, you plug them in. You put them into the equation and see if it works out to be true. So for instance, the first one, 5, -3, keep in mind x, y always. So we're going to say 3 times 5 minus -3 equals 7. We're plugging in the x and the y. So 15 plus 3, because minus and negative is plus, equals 7. I'm already going, that's not true. 18 does not equal 7. So that's not a solution. So you would say no, that is not a solution. Let's check the other one. Put the other one in, we would say 3 times 1 minus -4, because remember, this is x, this is y, equals 7. Then we would get 3 minus a negative is plus. 3 plus 4 is 7. Of course it is. 7 is 7. So the second one is yes, it is a solution. Okay, now, graphing an equation. Graph the equation, -2x plus y equals -3. The first thing to do is take this equation, which is in standard form, and get it into slope-intercept form. So, we need to solve it for y. Slope-intercept form always starts with y equals. So, we're going to get rid of the -2x by going plus 2x, plus 2x. That's going to leave us with y on this side. And we're going to arrange these two parts that are on this side with the x first, because we want it in slope-intercept form. So 2x minus 3. Now, we're done with that. The next thing to do is make an input-output table. Okay? And we are always going to want to choose our x's that are close to 0. Close to 0. And I want you to use 5 x's. So, choose -2, -1, 0, 1, and 2 for your x's. Now, sometimes you might have to adjust that. Sometimes you might have to choose 1, 2, 3, 4, 5. Or sometimes you might have to have all negatives. The way you decide is, if I use this x, is it going to make a big giant y that's going to be hard to fit on the graph? So you've got to use some judgment. Okay, so after you get your x's picked, you take your x and you put it in to the equation in x's spot, do the math to find y. So, let's start with negative 2. Negative 2 times 2 is negative 4, and negative 4 minus 3 is negative 7. That's our y. Let's put negative 1 in now. Negative 1 times 2 is negative 2. Negative 2 minus 3 is negative 5. When you put in 0, 0 times 2 is 0. 0 minus 3 is negative 3. Is anyone starting to see a pattern? There's always a pattern in the y values. Look for the pattern. That helps you to make sure you're getting it right. 1 goes in for x. 1 times 2 is 2. 2 minus 3 is negative 1. And 2 goes in for x. 2 times 2 is 4. 4 minus 3 is 1. See the pattern? It's going down by 2, or going up, I guess, by 2 each time. Negative 7 to negative 5, that's 2, that's 2, that's 2, all the way up. Okay. Now, next you graph the points, because these are ordered pairs. For those of you that have forgotten how to graph, you always start at the origin. So we're going to start at the origin, and we're going to go negative 2 over negative 2. Start at the origin, over negative 2, down negative 7. Okay, and we're going to put our point there. So, 2, 7 is right there. Okay? Then we're going to go negative 1, negative 5. So negative 1, oh dear, I think I counted wrong. 2, 4, 5. Oops, negative 7 is down here. So ignore my other blue point. We'll just kind of exit out for now. Alright, negative 2, 4, 6, yeah. Negative 1, negative 5 is right there. Okay, 0, negative 3. 0, negative 3. 1, negative 1. And 2, 1. And when you get those graphed, they should line up to be a line. So the last step is to connect the dots of your line. Connect the dots of your line, and always put arrows at the end. Also, don't make a little short line, make a nice long line, because you're trying to show that that line goes on forever and ever. Now you have graphed the equation negative 2x plus y equals negative 3. And you are done with this problem. Now, here's another equation. Y equals 2. For some reason, I don't know why, some people have trouble with this, probably because there's no x, and they freak out, and they go, oh my goodness, there's no x. Well, this is already in slope-intercept form, it's just that there's no x. Look, slope-intercept form of this could be y equals 0x plus 2. But since it's 0x, they just drop it and use this. There's no reason to have 0x. So y equals 2. Y equals 2. What does that mean? Let me tell you what that means. That means for every x in the entire world, y is always 2. So it's pretty easy to make an input-output table. When you use negative 2 for x, y is always 2. When you use negative 1 for x, y is always 2. When you use 0 for x, y is always 2. When you use 1 for x, y is still 2. When you use 2 for x, y is still 2. Get it? Y is 2, no matter what x is. So could we graph this really easy? Yes. Check this out. Negative 2, 2. Negative 1, 2. 0, 2. Y is always 2. I don't know why that won't draw on top of that. That's weird. 1, 2. I did not want to draw there. 2, 2. Y is always 2. So what you're going to get is a horizontal line that is at 2 on the y-axis. So that is the line y equals 2. So it's real simple. If you had another problem and it said, okay, y equals -3. Could you graph that? I can graph that without even making ordered pairs, because I can go right down here to y, because this is the y-axis, remember, equals 3, and say, oh, there's my line. Because if I did make ordered pairs for that, wouldn't I be saying things like 0, -3, and 2, -3, because y is -3? And all of those points are on this line. So anytime it says y equals 2, or y equals 1, or y equals 0, or y equals 5, or y equals -4, it's always going to be a horizontal line at that point. Pretty cool, huh? Now, we just saw what happened when we graphed y equals something. So what do you think is going to happen when we have to graph x equals something? Well, let's see. When it says x equals something, that means all of the x's have to be -4, because this says x equals -4. No matter what y is, x is -4. Okay, we can put any numbers in the world we want for y, but x is always going to be -4. Now, some of you are saying, well, Ms. Stephan, that's not a function. And you're right, it's not a function, but it is an equation. You're going to see real quickly that it's not a function, because check this out. -4, 0. -4, 1. -4, 2. -4, 3. So I'm going to have a vertical line headed at -4, and vertical lines can't be functions. They wouldn't pass the vertical line test, if you remember what that is. But that doesn't matter. We could still graph it. It's still an equation. Okay, so if I said, graph x equals 3, where would that be? Well, x equals 3, wouldn't that be points like 3, 0, and 3, -1, because x equals 3. So you go over 3, 3, -1, and you start to see real quickly that that's going to be a vertical line at 3. So every vertical line is easy to graph. X equals 5. There's the vertical line for x equals 5. It's at 5. X equals -1 would be right there. Every time it says x equals some number, then it's a vertical line. When it says y equals some number, it's a horizontal line. So these are easy to graph. Don't mess up the easy ones. Here's your video homework. If you can't remember how to do one of these, go back and rewatch the video. You guys are going to be awesome at graphing. Have a good night.